This video will review central angles, circles, and semicircles. To begin, let's start by defining what a central angle is. A central angle is any angle whose vertex is at the center of the circle. In this case, the central angle AOB has its vertex located at point O, which is the center of the circle, hence why we call it a central angle. Now, an angle's measure is the number of degrees typically, and the measure of that angle would be told, and we don't know what it is. It appears to be an obtuse angle, but we don't know what the measure is. But the question is, does the measure of the angle change the further we get from the center? To look at that, this would be the measure of angle AOB. And the further we get from the center, we'll see that it still stays the same. It's still angle AOB. So no matter where we take that measure of angle AOB, it's still going to have the same number of degrees, even when we get all the way out here, which is at the circle. Now that part of the circle is arc AB. And looking at the picture, I can see that the measure of arc AB would be the same as whatever the measure of the angle is. Therefore, this leads us to a justification. I can say that the arc measure, the measure of arc AB, would equal the central angle, whatever the measure of angle AOB is. And we'll use this in the next couple problems when we solve them. So let's take a look at some examples of how you might use arc measure equals central angle. Here's 3 problems. In the first one, we see that we're looking for x, and x is the angle. The central angle in this case is angle AOB. And I'm told that its intercepted arc, arc AB, has a measure of 108 degrees. Therefore, I know the measure of angle AOB equals the measure of arc AB because the arc measure equals the central angle. Now, if we substitute, we know that the measure of angle AOB is what we're looking for, and it's x, and we're told that the measure of arc AB is 108 degrees. Therefore, x equals 108 degrees. Take a look at the next problem and see what's different and what's the same. In this case, we still have a central angle and we still have its intercepted arc, but it's been reversed. Here we know the angle and we're looking for its intercepted arc. But it's going to be the same kind of justification. I know that the measure of angle AOB still equals the measure of arc AB because the arc measure still equals the central angle. The difference is we don't know the arc, but it's the same idea. The arc and the central angle have the same measure, therefore x is 52 degrees. Now take a look at the next problem. Here, the central angle, what we're calling x, or angle GOH, doesn't have the intercepted arc listed. That arc, HF, 120 degrees, is in the wrong place. So take a moment and look at it and see if you can figure out how we're going to find that arc in order to find angle GOH, in order to be able to solve for x. Now the key to this problem is we have a diameter. This GF, there we go, GF is the diameter of the circle. And that diameter is going to be huge in solving this problem. If we have a diameter, I know it goes through the center of the circle and it cuts it in half. If a full circle is 360, then that diameter cuts it into 2 semicircles, and each semicircle has a measure of 180, which means this whole side over here, this arc is 180 degrees. And that's how I'm going to approach this problem. If I can use the idea that the semicircle equals 180, I can take those two arcs, add together, solve for the arc that I need, and use that to find my central angle. So let's take a look at how to do that. I know that because it's a semicircle, the measure of arc GH, the one I need, plus the measure of arc FH, which is the one I know is 120 degrees, add to be 180. The reason, semicircle is 180. If I substitute and then solve, I'll see that the measure of arc GH is 60 degrees. And I can use that now. Now that I know that it's intercepted arc, I can find that central angle that I want. I know that the measure of angle GOH, the central angle that I'm looking for, would equal the measure of arc GH, which is its intercepted arc. And the reason is the arc measure equals central angle. Now I can substitute, and I see that x equals the piece that I need, which is the 60 degrees. Now I'm going to put one more example up, and this one's going to be a little bit tougher. Take a look at this one and see how you think we might approach it. Pause the video, try working it out, and then resume when you're ready. Alright, hopefully you've had a chance to work the problem. In this case, we don't have a diameter, so I'm not going to be using a semicircle. However, I see that there's 4 arcs that together make the circle. There's arc AB, which I'm missing, BC, which is 100 degrees, CD, which is a 20 degree measure, and DA, which is a 130 degree measure. Now I know the full circle is 360, and I'm going to use that to find the measure of arc AB. Once I know the measure of arc AB, I can use that to find my central angle, the measure of angle AOB, and that'll be x. So setting this one up, I'm going to start by circles 360, and I'm going to list out what arcs come together to make the full circle. If I then substitute in what I know about arcs BC, CD, and DA, I can then solve the problem. 100 plus 20 is 120, plus another 130 is 250. If I subtract that from 360, I get that the measure of arc AB is 110 degrees. And that's going to help me. Now that I know the measure of arc AB, I can find the measure of that central angle, angle AOB, because the arc measure and the central angle are equal. I can then substitute in that 110 degrees and the x that I'm looking for and find that x is 110 degrees. All right, thank you for watching this video, and I hope that it helps.